3.5.2 says determine the coordinates of L if it is given that KLMN is a parallelogram. So KLMN looks something like that. If we're to fill in the missing sides. Now they want us to find the coordinates of L. In this case, they want L to be such that this is a parallelogram. So we can use a variety of formulas. One thing about parallelograms is that we know its diagonals will bisect, meaning this side will be half of that side will be half of that side. So if we can somehow find the coordinates of this point, we can find the coordinates of that other point. So we can find the coordinates of this point by using the line KM, and then using those coordinates we can find our coordinates at L. But that's a bit too much work already. I want to show you the simplest method to solve this problem. It is not with diagonals, but rather just some knowledge of the properties of a parallelogram. So this is not really a property that is discussed, but it's something we know to be true. We know that opposite sides of a parallelogram are equal and parallel. That means the change from N to K will be equal to the change from M to L, because we know their lengths, or the lengths, are equal, and we also know that they are parallel, so they move in a very similar way, these two opposite sides. So if we can somehow find how they go from N to K, we can do the same thing and go from M to L. So from N to K, we need to think about it in two ways. We need to think about how they move from X and how they move from Y. So how do we get from an X value of 1 to an X value of -1 here? How do we move like that? So from 1 to -1, that's subtracting 2. And then from the Y value as well, we're moving from a Y value of -1 to a Y value of 2. That means we are adding 3. So we see for the X it's -2, for the Y it's +3. We can do the same thing for M. -2 and then +3. May not look it, but these add right angles to each other. So -3 -2, that will give us an X value of -5. Then we go X of L will be equal to -3 -2, that's -5 so far. Then the Y of L will go from -5 and +3, so that would give us 2. And that, or actually -2, though, that would be the coordinates for L. And this is not the only way that you can approach it. As long as you're using these sides, you can approach it from any kind of preference that you would like to. So as long as you're using parallel equal sides. So I did not need to delete all of that. Let's just delete this and try to get the same thing again. So we can do so like this. So instead of using these lines, let's see how N goes from, or these are still parallel, and these are still parallel as well. I'll just put it in the other direction, like that. Cool. So now let's see how N goes from N to M, and let's try to do the same thing for K to L. So from N, let's start with the X. How do we get from 1 to -3? That is by subtracting 4. Get to that point. And then how do we get from -1 to -5? That's subtracting 4 again to go down. So -4 -4, that's the translation. And now we're dealing with N to M. and we have K to L. So K to L, we're going to move minus 4, minus 4. Do you see that these triangles are kind of identical? So minus 4 and minus 4. So minus 1 minus 4, that gives us, so x of L will be minus 1 minus 4, that gives us minus 5. And then y of L would be 2 minus 4, which would give us minus 2. Therefore, the coordinates are still minus 5, minus 2. Just like they were here, minus 5, minus 2.